I'll move this one out of your way.
You're good.
All right, so here's the equation. So 2
Yeah, but if it's
SO2 gas.
they will-
So that's O2
Yeah,
gas.
if it was. It's
At equilibrium with 2 SO3 gas. All right, so 26 wants to know how each of the following changes affect an equilibrium mixture. Oh, so we're saying right, left, or no effect. So I'll do this. Right,
Decrease pressure, probably shift into the right.
left,
I guess you're decreasing
I'll
pressure.
say none. And then the other information that they gave us was that delta H was less than 0, which meant it's exothermic. So if it's exothermic, heat is on which side? Because that means if heat's released, right? If it's exothermic, heat's released on the product side. So we just think, since this is exothermic, we think about heat as a product. So the first one that it says is that SO3 is removed from the system. Okay, so if SO3 is removed from the system, well, we've taken SO3 away. Right, now we don't have enough SO3. So the reaction is going to shift in a way that needs to make more of what we just took away. So it would go to the right. So remove SO3 will cause it to shift to the right.
But if it was like endothermic, it would shift to the.
It wouldn't matter.
It wouldn't
The
matter.
only thing that will matter if it's exo or endothermic is where the heat is.
Okay.
So we'll look at the temperature, yeah, like when it's heated. So actually, if we look at that, so the reaction mixture is heated. So if it's heated, that means you're adding heat. So if I'm adding heat, it's like you're adding product. So now there's too much product. Right? So now you need to use up the product that you just added. And so what it's going to do, you need to use up the product that you just added. So if you need to use up products, that means you need to make more reactants. So that's going to cause it to shift to the left. So I'll just say add heat. One of them says the volume of the vessel is doubled. So here's where we need to think about the size of the container. So we have a container, right? Size of a container, whatever size it is, and you double the volume. So you make it this much bigger. What happened to the number of collisions inside the container? They decreased. Okay, so we have to think about it this way. When we increased the volume, we decreased the pressure. I have to write this down every time. So the change that we made by increasing the volume is that we decreased the pressure. Well, now to get back to equilibrium, we need to try to undo what we just did. So we need to get pressure back up. And so the way that this is going to change, if we need to increase pressure back up, is based on this, because it's all about the reaction shifting. So if the pressure needs to go back up, we need to shift to the side that will result from more collisions. So this is based on the number of moles of gas in the reaction. So changing volume and changing pressure doesn't have a set shifting like it would for like exo or endothermic. You always just have to look at the moles. So if we want more collisions, we need to shift to the side that has more moles of gas. So if we look at this, we have 2 + 1, we have 3 moles on the left, and we have 2 moles on the right. So which side would we shift? The left. So increasing volume would result in a shift to the left. A catalyst is added. None. Right? Catalyst doesn't affect it. Catalyst doesn't affect anything. Doesn't affect a shift. Doesn't affect equilibrium constant.
Make both sides happen faster.
Yes, just makes it happen faster. And then the total pressure is increased by adding a noble gas. That's the key word there. You're adding a noble gas.
Oh.
Pressure is changing, but it's changing by adding something that is not in here at all.
So it's not going to change it.
It's not going to change it.
Because they don't react.
Right.
When you said that today, I knew that I missed it.
Yeah.
'cause
And the temperature it just depends completely on exponent of that.
Yes, exactly. Yep. And then
Oh, jeez.
the last one is that O2 is added to the system. So now if we're looking at this based on O2, if we add O2 to the system, you need to make more products because now you have too many reactants, not enough products
That needs to shift
to the right.
to equal.
And do we have to do any ice tables or whatever?
I think Steve said there's one I did.
Okay. That's just